Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, and here we are at the last lesson for Chapter 6, Lesson 6.2.6, problem solving with similar shapes. Alright, so architects create scale plans for building houses. Artists use sketches to plan murals for the side of the buildings. Companies create smaller sizes of their products in stores. Each of these models is created to show all of the information about the real object without being the actual size of the object. Today you will work with your team to find strategies that you can use when you are missing some of the information about a set of similar shapes. As you work, look for more than one way to solve the problem. All right, so this first problem is going to involve scale models. Because Keenan loves trains, especially those that run on narrow gauge tracks. And it states the gauge of the track is the measure of how far apart the rails are. He has decided to build a model of the Rio Grande, I guess, what is that, a railroad? A popular narrow gauge train. Okay, so use the following information to help him know how big his model should be. Well, the first piece of information that they've given is that the real track has a gauge of 3 feet, which is the same as 36 inches. His model has a gauge of 3/4 of an inch. Okay, so those are the two corresponding sides there. So that's why I highlighted the inches, the 36 inches instead of the 3 feet. We need inches to inches. So 36 inches in real life is corresponding to the 3/4 of an inch of the model railroad track. So in this situation, it's important to note that instead of having an original and a new figure, we are working with a real track and a model track. So whether you want to consider the real track like the original and the model track the new, or going back and forth as we saw in previous lessons for scale factor, it really doesn't make any difference how we write the ratio. It's going to go in one direction or the other. So if we use the ratio that is greater than 1, that would be the ratio that would be used to go from the track, the model, to the real track. And if we were using the ratio that was less than 1, well, that would be for if we needed to go from information about the real track to the model. Okay, so now that we've got that in order, let's read the second part. The Rio Grande train he wants to model his driving wheel, or his driving wheels after, has a measure of 44 inches high. So we're going to use all of this information here, this information to help get our scale factor, and this information to help us find out how tall the tire or the wheel will be of his model train, since this is for the real one. So let's read that again to make sure that, I know the word model is shown in here, but read what this says. The Rio Grande train he wants to model has driving wheels that are 44 inches high. So the real train is 44 inches high for its wheels. So what scale, we're not discussing with our team, so I'm just going to jump to the question. What scale factor should be used? What will the height of the driving wheels of his model be? Okay, so take some time to think about this. Remember, these are the corresponding sides that you're going to use to figure out your scale factor. And then once you have your scale factor, you're going to apply it to this right here. Okay, take some time to think about that. All right, this is kind of a tricky problem. So I guess what we need to think about is the fact that the real is 36 inches and the model is 3/4 of an inch. And so if we want to figure out what the scale factor would be, we would have to write that as a ratio, right? As the real over the model. Let's just write it that way. And say 36 over 3/4 of an inch could be turned into a division problem, which is 36 divided by 3/4. And so if we go ahead and use that to figure out what our simplified scale factor should be, then we would take and multiply times the reciprocal, because we don't want to do a division problem with fractions, and that becomes 36 times 4/3, which is 48. So that means that the scale factor for this particular situation is 48. Now that would be if we were going from the model to the real. You would multiply this number times 48 and it's going to give you 36 inches. So if we want to go from the real to the model, then we would divide by 48 or multiply times 1 over 48 to figure out that answer. So let's go ahead and complete this. We know that in real life, the Rio Grande train has wheels that are 44 inches tall. So if we're going to figure out the model, we're going to have to go with the 1 over 48 as our scale factor multiplier. So let's go ahead and take care of that. You take 44 times the scale factor, and that gives you the fraction 44 over 48, which is a little bit less than 1, right? 44 over 48 is 11 over 12. So that means that for our final answer here, the height of his model train wheels will be a little bit less than an inch. It'll be 11/12 of an inch. Good problem there. Very, very rigorous problem we've got there. All right, so it says Heather and Cindy are playing a Guess My Shape game. Heather is to describe a shape to Cindy accurately enough so that Cindy can draw it without ever seeing the shape. Heather gives Cindy these clues. Clue number 1. The shape is similar to a rectangle with a base of 7 centimeters and a height of 4. Okay, so you're thinking in your brain, you're saying, okay, I'm picturing a rectangle right now with sides of 4 and 7, right? A height of 4 centimeters and a base of 7 centimeters. And then clue number 2 says the shape is 5 times larger than the shape it is similar to. So if it's similar to this, that means that the scale factor is going to apply to each one of those dimensions. Question A, has Heather given Cindy enough information to draw the shape? If so, sketch that shape. If not, write a question to ask Heather to give more information. Okay? And think about that. And if you think you know what the new shape looks like and the dimensions of the new shape based on this information given here, go ahead and write out that information here and go ahead and do the drawing right here. All right, so what do you think? I think she gave us enough information. There shouldn't be any trouble at all to figure out the dimensions. The dimensions are 35 by 20 centimeters. So how do we get that? Well, first of all, you start with the original description. She said it's similar to a rectangle is 7 by 4. So here's a rectangle that would have a height of 4 centimeters and a base of 7 centimeters. So your new shape has to also be a rectangle. And if you apply the scale factor of 5, 5 times 7 is 35, and 5 times 4 is 20. So this would have to be the shape that she was thinking of. All right, is this the last problem? I think, no, I guess we got 2 different problems. One more problem and a stoplight problem. So Nick enlarged figure A at the right so that it became similar to B. So this was the original A. It enlarged to B. Write all the ratios that compare the corresponding sides from figure B to A. Then identify what is the relationship between these ratios. And then thirdly, use 2 different ways to solve for X. Okay? And pause, copy these down, and address these 3 questions. Be sure to show all of your work for part C. Alrighty, are you ready? All right, so these have been color-coded. Maybe I should do that in advance. It seems like it's giving you a little bit of a heads up there, but I don't mind doing that. But it's always a good practice to show some way that you know which sides are the corresponding sides. So I color-coordinated them. And 2 corresponds to 5. So depending on, I guess this was the original and this is the new, so you'd want to write the ratio as 5 over 2 instead of 2 over 5 to follow in with that formula. And so then you'd have the 10 and the 4 that correspond to each other. And then you've got 7 and X that correspond to each other. So if we're going to figure out what the scale factor is, then we're going to take and simplify each one of those ratios. The scale factor would be whatever you multiply times 7 to give you X for an answer, right? And since X is bigger than 7, we want these ratios for the scale factor to be the ratios that are greater than 1. So what is the relationship of all of these ratios? They're all equal to 5 over 2, which happens to be our scale factor. And if you wanted to change that scale factor to 2.5, that would be fine to write it in decimal form as well. So now using two different ways to solve for x. One of them would be to use the scale factor. 7 times 2.5 is 17.5. So x has to be equal to 17.5. Or you could set up equivalent ratios to create a proportion. So if I use 5 over 2 is equal to x over 7, you could either look for a giant 1 and multiply 5 times 3.5, or you could cross multiply, which is how I'm showing it. 2 times x is equal to 5 times 7, and then 35 divided by 2 is going to give us our value for x. X is equal to 17.5. So both of these processes agree with each other and give us the same answer. Now for the last problem. Fatima solved for P. Here's P right there. In the diagram of similar triangles below and got an answer of 30. P is equal to 30. Now, this is a stoplight problem, which means there's a mistake that's very common to make here. We'll want to address this mistake so that we don't make the same mistake on our assessments and eventually on the chapter test that we're going to be taking very soon. So, looking at her answer, she knows that she has made a mistake. That happens a lot, right? Where you go through and you do some work and it's like this answer doesn't make sense, because in your brain a lot of times you estimate what you know your answer should be close to, and then when you don't get that answer or anything near it, you realize you've made some kind of a mistake. So what is the mistake here that Fatima made? What did she most likely do? Now, the first thing I would notice is this. These two triangles are not oriented the same way, okay? So remember, the corresponding sides are the sides that are in the same relative position to the original. So this side is the shortest, is going to correspond to this side. And the 50 side corresponds to the 75. Let me put 3 of them there, 3 of them here, which means that the 45 is going to be the magic side that corresponds with the P side. So whatever you multiply times 50 to give you 75, you have to multiply that number of 45 to give you P. So I'm almost certain this is what she did. I'm almost certain that she said that the 45 corresponds to the 75 because those are on the left-hand side, and the 50 corresponds with the P. Could that have been it? No, that's not what she did, because she got an answer of 30, and that would have given you a bigger answer than 75. I wonder where she made her mistake. I don't really know. Could she have done this? Could she have said 75 corresponds with the 50, so 45 is going to correspond with P? Could that have been the mistake that she made? Let's see. Let's cross multiply. We're going to get 75P is equal to whatever 50 times 45 is. 50 times 45 is 2250. And is 2250 divided by 75? I bet it is. Divided by 75, that's what she did. She got P is equal to 30, but this is the wrong process because the 50 and the 75 don't correspond to each other in this way. The 50 and the 45 correspond to each other this way. That's the way she should have done it. Because we need the 45 and the P together, you need the 75 and the 50 together, and actually, hold on for a second. I think the 50 and the 45 need to go together too. So let's put the P down here with the 75 and the 45 here, right? Because they're in the same triangle together. They're in the same triangle together. Stop it. But really? Hold on. Get you out of there, you sloppy little line. Why are you in there? Okay, there we go. So 75 and the 50, no, 75 and the P are in the same triangle together. The 50 and the 45 are in the same triangle together. The 75 and the 50 are corresponding sides, and the P and the 45 correspond to each other. That's the way to do it. So let's go ahead and get rid of this work here, and let's see what the actual distance is supposed to be. It should be 50 P's is equal to whatever 75 times 45 is equal to. 75 times 45 is 3,375. Is that right? No, that's going to be the right answer. Yes, this will be the right answer. Okay, so let's take this number divided by 50 and see if that answer makes sense. No, I want the calculator. 3375, now let's divide that by 50, and we get an answer of 67.5. P equals 67.5. Now let's take a look at this. Does it look like P is longer than 50? It does. That makes sense. 50 is a little bit more than 45. 75 has to be a little bit more than whatever P is, and that does actually work there. Now I'm going to solve this another way. Let's go in this direction and use our giant 1. I believe if you take 50 times 1.5, that's going to equal 75. Let's just verify that. 50 times 1.5 is 75. So if I take 45 times 1.5, I should get 67.5, and I do. Okay, so that is the correct answer. Now, they weren't asking for us to get the correct answer. They were just asking for us to determine what would make Fatima think that her answer is wrong. And so I think we covered that entirely. P is bigger than the corresponding side that has a value of 45, so it should be more than 45. And 67.5 is absolutely more than 45, so that's an answer that makes sense. 30 does not. All right, so we have come to the end of all of our lessons for Chapter 6. We are now going to start getting into a study mode to prepare for the Chapter 6 test number 2, which should be coming up within a couple of days. All right, take care. Let's head over to the homework, and then we will get into study guide mode. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.